First up now, Dr. Gerald North is Distinguished Professor of Atmospheric Science and Oceanography at Texas A&M University. He grew up in Knoxville, Tennessee, and has a PhD in physics from the University of Wisconsin. After a decade as a physics professor, he spent 8 years as a research scientist at NASA at the Goddard Space Flight Center before coming to Texas A&M in 1986, and where he then served as department head from 1995 to 2003. He has co-authored or co-edited several books and is currently editor-in-chief of the Encyclopedia of the Atmospheric Sciences, which will be published next year. He has won several national awards for his research, including the Jewel Charney Award given by the American Meteorological Society and the Medal for Scientific Excellence from NASA. Most recently, he chaired the panel on updating the statement on climate change by the American Geophysical Union, and we're very grateful he was able to come speak to us today. Dr. North.
Thank you very much, Tom, for inviting me, and to the other staff for their help. I'm going to speak for about 18 minutes, something like that, so just to give you a very brief overview of what's going on in the business of climate change. So that's me. I wanted to put my email address there if anybody wants to email me, and if you don't have a chance to do it now, you can hunt me down, just put my name in Google and go through the bad things about me. In my job, I get a lot of bad things too on the blogs, but anyway, you can find my website eventually, and you can then email me from there. Here's what we'll talk about briefly. The Intergovernmental Panel on Climate Change made its 5th assessment report late this past year, and I'll talk a little bit about that, where we stand with respect to the assessment of leading scientists in the world in the field of climate change. Then I'll tell you a few facts about climate change, just to set the record straight. And then we'll talk, I normally don't talk very much about going beyond the science and toward policy change, policy ideas and thoughts, but in recent months and the experience with the AGU panel that I chaired has convinced me that it probably would be a good idea if more scientists did talk a little bit about those things. So I'm going to do that today. So who will win and who will lose as climate changes? What needs to be done? That's how I'll conclude. So what about the IPCC report? Well, it turns out there were really no great surprises. They sharpened some of the language. Progress in this field is incremental now. It's not these big steps forward. We occasionally see something, but basically we're boiling down to taking more data, getting more precise information that helps us to improve our climate models. That's a very, very incremental and hard-working process. So the uncertainties in climate modeling and our projections into the future are still very large. When we ask what happens to the global climate if we double the CO2 in the atmosphere and wait for it to come to equilibrium, the answer is about 3 degrees Celsius warming, but we only know that number to about plus minus 50%. And in fact, in 1979, there was a report published that had exactly the same statement in it. So before we started any of this 30 years or more of research, we still have that. We understand the problem a lot better, but in fact, this is a very, very difficult thing. When we think about econometrics and things like that, I think it was Alan Greenspan who said, well, these models are worth nothing, but they're really useful to unpack and figure out what just happened. So we're a little better than that with climate change. I think we have the laws of physics to help us, but it still is very uncertain. So there is a wide margin of potential outcomes, even if we know exactly what humans are going to do about putting more CO2 and other greenhouse gases in the atmosphere. So that's a fact. We have to live with that. And it will probably improve in the future, but don't expect too much too fast. We have to be realistic. Oh, sorry, I think I hit the wrong thing. Forgiving. So essentially, no change in the projections, except that sea level change is expected to be a little bit higher than it was in the last assessment report, which was 5 or 6 years ago. And the reason for that is they were a bit conservative in number 4 about the melting of ice on Greenland. I think we have made serious progress in understanding that problem since the last report. And I think that they were a little more bold this time and say, yes, Greenland is clearly losing mass at a fairly large rate, and so is Antarctica. So Greenland is losing mass. All of that mass of ice goes into the ocean and contributes to sea level rise. The biggest contributor to sea level rise, though, is not actually the dumping of ice into the oceans, but rather the swelling of the water just from heating it. It expands a bit, just a tiny bit, but when the thing is 4,000 meters deep, a little bit comes to a meter or so. So by the end of the century, it could be as much as a meter. And that would be fairly important if you are trying to run a port, things like that. And if you're watching out for hurricanes, because the surge of flooding really jumps if you raise the sea level just a little bit. Places like Houston, where not only do you have sea level happening, but the land is sinking. So this is a serious problem for that part of the country, and other parts all along the coasts of both coasts in the United States. So no change for hurricanes. We think maybe, theory says, that the hurricanes in the future are probably going to be more intense, but we don't know that for sure. It's a theoretical thing at this point. Statistics are just too hard to use. We do use them, but there's a lot of bias and confusion in the statistics because the record, the way we've been able to identify hurricanes has changed over the years. First, it was just an airplane goes over, it spots one. Now we have satellites, so we observe more now than we did, but we probably missed a lot of those in the past. So we don't know much about what's going to happen to future hurricanes. Here is a big one. The ocean will be acidifying, and the reason for that is the more CO2 we pump into the atmosphere, the partial pressure of CO2 pressing on the ocean causes the ocean to dissolve more CO2, just like your Coca-Cola or Pepsi, whichever you prefer. The pressure of CO2 on the surface of the ocean causes more ocean water to dissolve the CO2. And when the CO2 is dissolved, it turns into carbonic acid and other acids. And these can really mess up our lobster tails and clams and all kinds of shellfish below the surface. Corals, all that. So this is a major thing to think about, and many of the tricks about geoengineering, reflecting back some sunlight to make up for the CO2 increase will not cure that one. All right, so that's the IPCC. Now just a couple of facts about climate change to make sure that we know what we're talking about here. Let me see. This is the pointer here. Where's the pointer here? Ah, it's this one? It's not that one. How about that one? No. That one. There. But not very bright. I should use the one the complimentary one in my pocket. Let's try this one. Yes. Thank you. So here's the carbon dioxide since 1958, one of the very famous curves in all of the geosciences by Keeling. It's called the Keeling curve, taken in Hawaii. Of course, we have measurements now all over the world, some of them starting later, but all showing the same trend. And so now, just this year, we've probably hit 400 parts per million, and you can see that it's going up. If you look carefully and look at the emissions data, this is really exponential. It's going up exponentially. The temperature response to an exponential increase in CO2 should be linear. And so let's see what that looks like. Here. We're not advancing. I can do that here, maybe. Yeah. So here's the temperature curve. This comes from the Goddard Institute for Space Studies in New York City. And so what you see is this trend upward, which is here, of about 0.8 degrees Celsius per century. And I think that one mistake that many people, the merchants of doubt and all the others, make is that they expect that any little turn down like this, well, that's the end of global warming. It's not really happening. Of course, some of that has happened up here. And of course, it's gotten a lot of press from our friend. I think this one's gone too. I'm wearing out all the batteries. But the wiggles here really mean nothing. The ocean system can take up large amounts of heat and then spit them back and so forth. So in fact, many people were disturbed from 1960 up until 2000 because of that really steep rise. Well, that was probably faster than the long-term trend. And some of these dips that tend to cool the Earth are probably also just anomalies because of the natural fluctuations in this very complicated system. And here is a picture of what we might expect based on the climate model simulations in the IPCC number 5. What you see is that the planet, mostly in the northern hemisphere, the northern polar area, is warming very rapidly. The land is warming a little faster than the oceans, also not a surprise. Even very simple models show that. And on the right, of a little bit more interest, is I'll try one more time on this one. Sorry, I'm moving from one house to another, and I think my own personal one is in a moving van somewhere. Anyway, so let's move on. So, on the right, you see precipitation. And if you look closely, it shows that in our part of the country, especially the American Southwest, precipitation is expected to be less. Well, with precipitation less and temperature going up, that's a bad sign. That means arid areas in the subtropical part of the world, and let me define that for you right here. These are data from a satellite that I was connected with when I was at NASA, and many years after too, supported lots of graduate students. The white areas there are the so-called subtropical areas, and there is no rain there. Those are basically drought areas. You can see Saudi Arabia, the Sahara, but also out over the oceans. And notice, though, what's suggested. Oh, we have. What's suggested? I'm getting some help. What's suggested is that the white areas will be expanded poleward. Their poleward edges, both in the northern and southern hemispheres, will be expanded. And what that means is less rain in our American Southwest and in many other places, Europe included, and more rain up in Canada and the northern tier. Basically, the storm belts around the Earth will be advancing toward the poles in both hemispheres. This is a very robust finding of the IPCC over many years. So here is a kind of schematic of how the air rises along the equator, sinks in the middle, in the subtropical areas. That's the white areas in the upper graph. No rain there. So climate change, the bottom line is the arid subtropics will expand, and this will have a huge impact on agriculture in the United States and in other places. Here is a graph showing the pH, that is the acidity, a measure of the acidity of the oceans, and it's noticeably going down in the last 20 years. Very extensive and accurate measurements show that. And so what you see off to the right in the graph are different scenarios of our future, depending on what our emissions will be during that time.
If that one's any better.
Let's try it. I've forgotten now which one is. Yeah, it is. Thank you. Okay, so winners and losers. Well, there are ethical issues that really people should think about here, not often talked about. But who really should pay for this? We just sort of sweep that under the rug. I mean, one that I've heard of and I've sometimes talked about in my classes is by the philosopher John Rawls, who says, well, you shouldn't do anything in policy here that would make the poorest nations in the world worse off than they are before you started doing it. Managed and unmanaged systems. This is a thing that you folks in here are very, very involved in. For example, just contrast a couple of differences between managed and unmanaged systems. The U.S. economy, we think is a managed system. There are probably debates about that. U.S. agriculture, big farms, so forth, managed. Corporate farms, those are managed systems, railroads, other things. What about unmanaged? Well, the ocean circulation, we can't manage that. Hurricanes, we can't manage that. Ocean acidification, those are unmanaged systems. Extinction of species, we really have a very hard time managing all of those. So your job in the efficiency business and thinking about those things, all over on the left-hand side, what can you do with managed systems that will make them more efficient and therefore less problem for our world climate. So here are just a couple of notes that I'll make. I'm not going to go through that old table. That would be very unkind of me. The heavily managed sectors, this is for the U.S. economy, and this comes from a book, a recent book by William Nordhaus at Yale University, an economist, and I have the reference to it on the next slide, I think. In any case, so here are some heavily impacted segments, and here's how those segments have changed in the United States from 1948 to the present, 2011. So you see, things like farming were something like 8% of our economy, now only about 1%, forestry and so forth. So the contribution to our GDP has gone down tremendously in these. These tend to be areas that are in the managed side. So what's happened here is a lot more efficiency in those sectors, so their contribution goes down. All right, let's move on. Here is a graph of extinction of species coming up to the present. We see that these things may be heading upwards. What needs to be done here? Well, in Nordhaus's book, which I don't seem to have, that may be, yeah, I'm showing it here, but not on the screen. But Nordhaus's book called The Climate Casino. Here we have another one, okay. Green, this is a good one. Green, that fits the audience too, right? Okay, so notice that the sources of CO2 from coal, oil, and other resources is about the same for the globe. The ratio of these different sources is about the same for the US and for other parts for the whole globe. That's interesting. And here's another one that just shows something about emissions for different activities in US households. And we're quite a ways along here. I'll be off the stage in just a minute. So automotive travel, this is for individual households. This is 7.9. And as you go down, you look at the different things that we do, air conditioning and so forth, more of that, of course, in Texas than other places. But it turns out that everything else is really a big contributor versus all the things we do in our house. For example, when we buy goods from China, the greenhouse gases were actually emitted there. But in fact, we get the good from those products here. So a lot of the greenhouse gas emission is really out of control of our households. That's an interesting point for us here. Now, Nordhaus, and I really highly recommend his book. It's called the Climate Casino. I think it's Yale University Press, but I'm not sure. You can find it on Amazon. Very, very good book. It can be read and understood by anybody in this room. So, projection of the most economical way, and what Nordhaus does, he's a specialist in cost-benefit analysis of economic outcomes of different policies. And what he's done, and this one was not done by him, but corroborated by his work, by the U.S. Energy Information Administration, what they show is the most economical way for the United States, our country, to reduce emissions by fuel type is that we need to do something about coal. Coal is the problem. So the more we use natural gas and so forth, the more we push this down. And the more efficient we are, even when we have to use coal and don't have any other choice, the more efficient we are, the better off we are in terms of our production, our emission. All right, so now I'm going to wind it up. So the climate is changing, there's no doubt about that. If anybody wants to argue with me, we can meet outside. It will get warmer, more arid in most of the subtropical areas. This will lead to water problems, both here but many other places in the world. There will be large water problems. So water problems can cause all kinds of international conflicts and problems. So the ocean will be more acidic. This is a big problem that I think we're just now beginning to notice. There was a piece on the news a week or two ago about the cost of lobsters and clams and things going up. And they argued, and I don't know about this, but they argued that this is already becoming a problem. Certainly we see the coral being affected. Mitigation, that is the prevention, is imperative, but adaptation has to play a role in this. There's no way that we can, politically, this is so difficult. I think that will be achieved eventually, but maybe not for decades, satisfactorily. So adaptation, that's the business that many of you are in. How can we make our systems more efficient in order to reduce emissions? Coal burning is the main emitter of CO2 worldwide, no question. We need market mechanisms to curb it. And Nordhaus, and I agree with him, he says you could use cap and trade, you can use a carbon tax. It really doesn't matter which one. Either one would be fine. Whichever one is politically the most feasible to have happen would be the one to go. Poor countries will suffer most because of the vulnerabilities. Actually, the United States probably would not be disturbed terribly much. This is really a remarkable thing. Because of our highly efficient systems, most things are managed here, just not a big problem. Agriculture would be very vulnerable, but it's only a very tiny part of our economy. The really difficult problem is that questions that involve values that we cherish. Species, annihilation, many other things, the loss of natural environments, all these things are problems that are extremely hard to put into cost-benefit analysis because we can't quantify them. Ethical problems, all those things, very hard to quantify. So that's all I have to say. Thank you.